Greetings, intermediate algebra students. Time for lesson 10.3 on factoring trinomials. I'd call this the meat and potatoes of this whole chapter. If you guys can figure this out, hi Adidas, there's my cat here helping me do this. If you guys can figure this out, you'll be in good shape the rest of this chapter. Now, what I have here is a multiplication of binomials, and we did this last chapter in chapter 9. Let's just review how to do this. You could use the FOIL method. Of course, x times x is x squared, and x times 4 is 4x. I'll change colors here, and we'll do the rest of the FOIL method. The inside ones, negative 3 times x is negative 3x, and negative 3 times 4, of course, is negative 12. Typically then when I do this, I can put together my middle terms, and so my final answer then is x squared plus x, 4x minus 3x is 1x, minus 12. Now again, as we've mentioned, what we're doing in chapter 10 now is we're going to reverse this process. So we're going to start with this, and then we're going to try to get back to this. So that's our task, and fairly tough until you get the hang of it a little bit. So we're going to actually just tackle some examples here. We'll practice this a lot in class. You really have to work hard in class trying to figure this out as well. Here's our algebra tile idea, and again we think this can be fairly helpful here in trying to figure out how to do some factoring. Now as you can see, what we have here, this square does represent the trinomial x squared plus 6x plus 9. The x squared is represented by this big square here. 6x, remember the long tiles here, those represent x, and sure enough we have 6 of them. And then the 9 are the little yellow squares, and we do have 9 of those little yellow squares. So by factoring this, we're trying to break this apart into usually binomial factors, 2 terms. Now if we take a look here on each side, notice what we have. On my length here, notice I do have an x, that's the distance from here to here, and then I do have 3 of these x terms, but remember the width of each of these is also 3, isn't it? And the same thing on top, I have an x and a 3. Therefore, we can say that the factored form for this trinomial is x plus 3 times x plus 3. And sure enough, if we FOILed this out, we would get my original trinomial here, x squared plus 6x plus 9. So for some of you, this visual way might be kind of a helpful way to do factoring. And again, that's an option on your assignment card on the right side, that you can use some algebra tiles to show how a certain trinomial can be factored. We won't do that. We'll go for more of an algebraic approach when we do these. So let's just tackle these. Now remember, our first thing we look for when we factor trinomials is always a common factor. So if I look at this first trinomial here, yeah, there's an n in the first and second term, but not an n in the third one. 8 and 12 have some common factors, but then this term doesn't. So I don't have any common factors. So that's when I would usually then make my 2 sets of parentheses here like this and do that FOIL method in reverse. Well, I know that whenever I have something like n squared, or just one variable like that without any coefficient or number in front of it, that's just going to be n times n. The first times the first, n times n is n squared. And after that is where it gets interesting. If you look at our last term here, which is 12, we know that whatever I put here and here, that has to multiply together to give me 12. And whatever I put here and here combined with this and this, that has to give me 8n. Sometimes it's good to list some factors of 12, or numbers you can multiply together to get 12. Well, I have 3 and 4 I have 6 and 2. I have 1 and 12. Those are pretty much my factoring options there. So I want to look at those, and the key thing, I want the sum of those to be 8. And so I think you can see that the option that I'm going to choose here then is 6 and 2. So my answer will be n plus 6 times n plus 2. And sure enough, if we FOIL this out, we'll have 6 times 2, which equals 12. And I'm just going to use a different color here. My innards and outwards, sometimes I call them, we have 6n here, we have 2n here, and sure enough, 6n and 2n is 8n. Alright, kind of tricky, but, well, maybe I won't say fun, but certainly a good sense of satisfaction when you can unlock the puzzle of these trinomials. Alright, let's try the next one. Again, no common factors, so I make my 2 sets of parentheses here. And obviously it's going to be k and k. Now this is a little trickier because now we have a negative sign in here, a negative sign here, so that just makes a little bit more complicated, because in order to get a negative value here, one of these is going to have to be a positive number and one's going to have to be a negative number. That's the only way I get a negative number when I multiply. So again, if we think of some options to get 15, well, 3 and 5 are the ones that come to mind first. 1 and 15 are probably my other options, but 3 and 5 is going to be it, because once again we have to get that negative 2 in the middle. So 3 and 5 are certainly 2 factors that differ by 2. Now, how do you decide which one goes here and which one goes here, which one is positive and which one is negative? Well, trial and error oftentimes is what you have to do. Otherwise, noticing that this term in here is negative, that's probably the sign that the bigger factor has to have. Let's try that. I'm going to put a 5 here and the 3 here. Now, it's always good to kind of check, and so let's see what we can do here when we check these. Again, k times k is k squared, 3 times negative 5 is negative 15. The ones we have to check are these innards and outards. So here I get positive 3k, here I get negative 5k, and sure enough, if I add those up, that will give me 2k. So I did my correct factoring there. But it's kind of tricky. Slide, look at this bear cat. Now this one is going to be doubly tough because, as you can see, now we don't have just a single x or y squared, it's a 6 there. So we have a number of ways we could get 6, like 3 and 2 or 1 and 6. Also, we have 5 here, which will make it a little bit tricky. Now again, we always look for what? Common factors. So there's no common factors here, so that's when I can start to make my 2 sets of parentheses. Again, this is where you just have to use a lot of trial and error. I'm just going to go with 2y and 3y here, because certainly 2y times 3y will give me 6y squared. Again, when I see this 5 here, there's not a lot of factors I have to get me 5. Probably just 5 and 1 are my only choices. But the question is, where does the 5 go, where does the 1 go, that type of thing. So let's just try and put it here like this. Let's put a I'm going to put a, let's get my pen going here, I'm going to put a -5 and a +1. Okay, clearly it works for 2y times 3y is this. Clearly it works for 1 times -5 is this, but let's check my innards and outards here. So, if I do that here, I'll get positive 3y. Here I'll get negative 10y. And does that give me my middle term? Well, 3 and -10 is -7. Ugh. So it doesn't work. That must not be the right combination. So I'm going to get rid of this, and highly encourage you to use pencil on these kind of problems, because you're going to make that same mistake when you do some trial and error like this. Oops, I got to erase one more thing here. So I have to erase, oopsie, where are you, eraser? just lost my eraser somehow. Oh, here it is. Okay, I think. Oh well. Well, we'll just redo this then. I thought I could probably erase this, but maybe not. I'm going to try to do this and this. Let's go to this eraser again. How come I can erase this and not this? Strange. So anyway, I'm going to have to write over this, so I'm going to change colors here, boys and girls. So clearly it's not 1 and 5, and the answer actually, well, it has to be 1 and 5, but probably just not in this particular case. So I think this is going to have to be minus 5 right here and plus 1 over here. Sorry, I can't erase that. Again, if we check this, my innards and outers, now I'm going to have negative 15y for my innards, and my outers will be plus 2y. And sure enough, if I combine those together, I'll get negative 13y, which is what I want up here. So here's my correct factoring, 2y minus 5 times 3y plus 1. Again, those are kind of tricky. We'll be practicing on those in class certainly quite a bit. Thanks for watching, and we'll see you guys then.